Hey guys, this is another section here in geometry. This is chapter 10, section 3, and this is called transformations on the coordinate plane. And, once again, we're always going to stick to new vocabulary terms that are all the way through here on the left side. We're going to be talking about a lot of those throughout. So we're going to start right here. Again, the title is Transformations, and that term is used to describe different things that can happen, right? So it says it right here in this first sentence. A mapping of a geometric figure that may change its shape or position is called a transformation. Every corresponding point on the figure after a transformation is called its image. So when it's transformed, when it's moved, it shows you a little example down here of a transformation. But there are three different types of transformations that we're going to talk about in this area. So transformations is the big word. Then we go into the smaller versions of what a transformation is. So the first one is called a translation. And so a translation is when you slide a figure from one position to another without turning it. So we call those slides. And so notice the letter E in blue here. That is the first, that's what we're translating, sliding. And notice that it slid to the green letter E. So it went down 1, 2, 3, and then it went to the right 1, 2, 3, 4, 5. So it had a translation of 3 down and 5 right. And then our next transformation is called a reflection. That's when you flip a figure over a line. The line is called the line of symmetry. So we can call the reflections, another word for it is a flip. And so we have a line of symmetry down the y-axis on this problem. And we're taking E, the blue E, and we flip it over the line. What I want you to notice is that every point is now the same distance away from the line. So this little point right here is 2 away. This point right here is 2 away. And so that happens throughout. You flip it over the line. It's the exact distance on the other side of that line. The last transformation is the dilation that we're going to talk about. The dilation, and that is when you enlarge or reduce a figure by a scale factor, which we've talked about, with respect to a fixed point. This is the one that gets the most confusing for people. The fixed point is called the center, and the resulting image is similar to the original figure. Right? We've talked about similar figures last chapter. And so a dilation creates similar figures, right? One E is a little bit smaller, and then the other E is bigger. And in this example, the scale is 3 times bigger. And it's also 3 times the distance away from the center, which they chose the center as the origin. For first learning dilations, it's probably easiest to start with a center point at the origin. That makes just a lot of the dilations a little bit simpler. All right, and so we're going to continue going down. And here's a couple more examples of dilations. We've got, let's start with the translation. So in each of these examples here, we've got translation 4 units to the left. We start with the blue figure, and so every point moved 4 units to the left. All right. And the other thing I want you to notice here is this part. All right. This is called reading math. All right. There's ways to read things when you're talking about geometry. And it says the notation M with an apostrophe, right there, is read M prime. It corresponds to point M. Well, down here, we had point Z, and it moved to Z prime. And so you put one apostrophe to show, hey, that's the first position that it moved to. And if we moved it again, we would simply make the next point Z double prime. Okay, and that's just a way to read the math here. So as you see that, that's what's happening. Here's a translation 5 units down, A to A prime, B to B prime, C to C prime, and then D to D prime. They all move 5 units down. And then translation 6 units right, 3 units up. Every point, starting with the blue, went 6 right, 3 up. 6 to the right, 3 up. 6 to the right, 3 up. And that is 3 different versions of translations, a type of transformation. All right, kind of using both words there. Sound the same, but let's keep on going. And I'm going to go ahead and do example 1 here. It says that triangle MNP is shown on the coordinate plane. Find the coordinates of the vertices of the image of triangle MNP, translated 5 units left and 3 units up. All right, so I'm just going to take M and go 5 units left and then 3 units up. 1, 2, 3. That puts me at -1, 1. So M prime is either that one, A, or C, right? Because M prime in B and D is not -1, 1. And so I'll check on N. N needs to go 5 units left, 3 units up. That puts that at -5, 5, which is that point, which means that our answer is C for this problem. All right, I didn't even have to check P because I already know my point. All right, let's keep going here. Let's talk about reflections. So a reflection, in this case, there's usually 2 different ways to do this. You either do a reflection over the x-axis or a reflection over the y-axis. And so what I want you to just keep in mind is, blue is the first figure, green is the image where it's moved to, and this one is flipped over the x-axis. Notice that it's 1 unit apart, 1 unit away from the x-axis, and these E points, E and E prime, are also the same distance away from the x-axis. All right, and then a reflection over the y-axis on this side. Y-axis, y's are the rise, so that's the one that goes up and down. And notice every point is the same distance away from the y-axis. All right, let's take a look at example 2. It says the vertices of a figure are -2, 3, 0, 5, 3, 1, and point D is 3, 3. Graph the figure and the image of the figure after reflection over the x-axis. And so, when it gives you all 4 points, you're going to go ahead and graph those. And then since we are flipping over the x-axis, one easy way to do this is, just counting the distance away from the axis and creating that same point on the other side of the line. When you get up into high school geometry, we'll be showing you a little bit more complicated version of that, but a very cool, needed thing when you get up there. So that is a reflection. And the last one here is the dilation. All right, so let's talk about a dilation. Diagrams below show how dilations result in similar figures that are larger and smaller than the original. The center of each dilation is the origin. So that's what they're telling you in here. They're making the center of the dilation the origin. That's not always the case when you get up into upper levels of math. They will show you different points of center for dilations. They're starting at the origin, and one thing that's happening here is they're telling you the scale factor. So the scale factor of 2, any number that's bigger than 1, when the scale factor is bigger than 1, means that the figure will get bigger. All right. And then in the other example here, the scale factor is 1/2. Anything less than 1, less than 1 will result in a smaller figure. How about a scale factor of 1? What would you suggest that would be? Well, it tells you right here. If k is 1, the dilation is congruent to the original figure. So in other words, scale factor of 1, the figure is exactly the same size. All right, bigger than 1, it's bigger. Smaller than 1, it's smaller. Exactly 1, it stays the same size. All right, and so basically what you're doing here is taking each point and multiplying by the scale factor. And that works because the center is the origin. And that's probably the simplest way I can describe it for this point in time. Take each point, take A is -1, 2. And since this is a scale factor of 2, we take that point and multiply both numbers by 2, and that tells you where to graph A prime. And you do the same for each B, C, and D. Same goes for the other point you're going to take on the right side. You're going to take each point, times it by 1/2, and that creates a new point. So for instance, point X down here is, what's it look like? It looks like 2, -3. And so we're going to take that and multiply by 1/2. The new image, that would be 1, and 1/2 of -3, 1/2 times -3 is -1.5. And so that's where X prime is graphed. All right, and you do that for each point. And down to the next example, example 3. And lastly, it's got a concept summary here that I'm going to read with you. So it says, translations and reflections produce images that are the same shape and same size. Those figures are congruent, right? So you have congruent shapes with translations and reflections. But in dilations, you get similar shapes, right? Because the object is getting bigger or smaller, it creates a similar figure, which means the lines, the length of the lines are proportional, but the angles all still stay the same. Except the only time that we get congruent shapes is when the scale factor is exactly 1. Okay. I'm going to also let you see the rest of these examples. So if you're needing more practice problems, here's 1 through 4. You can pause your screen. Here is 5 through 12. All right. And notice, as you're watching this too, that this box right here tells you how to do each example. So you'll go to example 3 on what I just showed you to do problems 5 through 8, example 2 to do problems 9 through 12, and example 3 to do problems 13 through 18 here. And so by examples, I'm talking about what I just went through in the notes. Example 1, example 2, example 3 to do these problems that are in here. Okay. And let's keep going. I'll show you 13 through 18. You can pause your screen once again. I don't know why that keeps following me. Still doing it. And there's 19 through 27. And the rest of those. All right, guys. Thanks a lot.